EET 105, Chapter 1, Introduction to Basic Math. Okay, the first thing we got to go over is Section 3, Units of Measurement. And it's showing you a basic formula here for velocity equals distance divided by time. So if you assume the distance is 4,000 feet, time is 1 minute, it's showing that, if you divide the distance by the time, you're going to get feet per minute. But that's not equal to 4,000 miles per hour, obviously. What you have to do here is do a unit conversion. So 1 mile equals 5,280 feet. 4,000 feet is 0.76 miles. What they did was they took 4,000 divided by 5280. And then 1 minute is 1/60th of an hour equals 0.017 hours. So you take that 0.76 miles divided by 0.017 hours and get 44.71 miles per hour. And you can't just say V equals 44.71 without including the unit of measurement, or else it would be meaningless. Uh, each quantity has the proper unit of measurement as defined by the equation. So units are very important when we're speaking about, an answer or solution to a problem. The proper magnitude of each quantity as determined by the defining equation is substituted. Each quantity is in the same system of units or as defined by the equation. System of units meaning English or metric primarily. Um, I remember a story years ago about one of the Mars orbiters that went to land on Mars, and they used, they had two teams working on it from NASA. One team was using metric, and the other one was using English. And then when they put the code into the robot, it actually the retro rockets fired at the wrong height and then ended up crashing down to the planet, and of course they lost the lander. Each quantity is in the same system of units, which is what we just talked about. The magnitude of the result is of a reasonable nature when compared to the level of the substituting quantities, meaning you're not getting an outrageous number. You're not getting a really huge or really small number, something that makes sense. I mean, use common sense. The proper unit of measurement is applied to the result. Okay, so if we're talking about voltage, we're not going to answer in amps or watts. Common systems of units are in table 1.1 here, and it just shows you examples of English units, and then the comparable metric units and MKS and CGS, and then an SI. Okay, the only real unit that we're going to be dealing with in EET is joules on this page. Significant errors, accuracy, and rounding off. So, you know, in the addition or subtraction of approximate numbers, the entry with the lowest level of accuracy determines the format of the solution. So, example, if you have a number in the hundreds, like let's just say it's like 0.03, and then you have another number that you're doing a calculation that's in the thousands, then the hundreds is going to dictate it dictates the level of accuracy. So the lowest level of accuracy. For the multiplication and division of approximate numbers, the result has the same number of significant figures as a number with the least number of significant figures. Again, it would be this one. This has the lowest number of significant figures, which would be 1. Actually, they both have one significant figure. And then powers of 10, very, very important. Know your powers of 10. There's a table right here that shows you anywhere from 1 to 3. 1 equals 10 to the 0. Anything to the 0 power equals 1. And then 10 equals 10 to the 1, 100 equals 10 to the 2, 1000 equals 10 to the 3, and then 1/10 equals 0.1 equals 10 to the minus 1, and so on. This is 10 to the minus 2, 10 to the minus 3, 10 to the minus 4. So what you can do to if you want to count is you see where this decimal point is, and you count over, 1, 2, 3, 4 equals 10 to the 4. Okay, this actually equals 1 times 10 to the 4th power. And then this is counting over 1, 2, 3, 4, 5. So this would be 10 to the minus 5th. But if you had like a 3 here, if that was 0.00003, then it would be 3 times 10 to the minus 5th. So this is the general formula for division. This is division powers of 10. 1 over 10 to the n power equals 10 to the minus n power, and then 1 over 10 to the minus n equals 10 to the positive n. Addition and subtraction. To perform addition and subtraction using powers of 10, the power of 10 must be the same for each term. So these two n's are the same. And then all you have to do is add or subtract the b, and then you multiply by that power of 10, whatever that n is, it's going to be an integer. The product of powers of 10 multiplication, 10 to the n times 10 to the m, you add the n plus m. So in general, if you have a and b involved, a and b2 and b and they could be any number, you would do a times b times 10 to the n plus n power. And then division, likewise, a times 10 to the n divided by b times 10 to the m equals a divided by b times 10 to the n minus m. Now remember, these numbers can be positive or negative. So if you had negative 2 on the top and positive 3 on the bottom, then it would be negative 2 here minus a minus 3, which would be minus 2 plus 3. If n was minus 2 and m was minus 3. Okay, so just remember that it flips signs on the bottom. And then the powers of the 10 is 10 to the n power, everything to the m power. You just take n times n. So example here, a times 10 to the n power whole quantity to the m power equals a to the m power times 10 to the n times n power.